Well, I was very rudely cut off there. This is still physics video number 9, and I was getting cut off here when I was talking about the 3 forms of energy. Apparently the flip camera didn't like that. But there are 3 forms, remember: work, potential, kinetic. And so I want to go to the sheet right here. I was looking 38, when you move something, work is done. So when you displace, when you move something, work is done. If you're holding a baby, or a calculator, or a baby calculator, if you're just holding it there, work is not being done. If you lift it up, potential energy is being gained, work is being done. You're putting energy into it. But just holding it may strain your muscles, but work is not being done. Think about that. Energy, 3 forms. So work takes energy, work is energy, PE, KE, and work. Power, right here in blue. Power is the rate at which work is done. We did the power lab, we boogied up the stairs. Some of us just walked up the stairs. And you did a certain amount of work, gaining potential energy because they're both in joules. And then the work that you did should gain you the same amount of potential energy. We timed it, and that was joules per second. And joules per second is equal to watts. Watts and watts of power. That's right. And remember, when you're thinking about power, you got to think of, I got the power! Ba, ba, ba. Anyway, okay. So now, this graph right here. No, that's not going to show up, Mr. Wilson. Put it down here. Work over time. Think about that for a second. Work divided by time. What this means is time goes on, you're doing more and more work, but the rate is, you know, the slope of this, which would equal power, is constant. So this is a constant amount of power. If this were curved up, it means you're putting in more power. It's kind of like you're putting the pedal to the metal. You're accelerating if it's curved up. So that's the key thing right there. All right, does NYSEG sell power or energy? Well, NYSEG is a bunch of bloodsuckers. And if you're watching this NYSEG, I hope you see this, because you charge a lot more per kilowatt hour, about 13 cents, where people in just Pennsylvania, not Pennsyltucky, as I sometimes call it, but Pennsylvania, they pay more, like 6 cents a kilowatt hour. Why do they pay about half, less than half? That's a good question. All right, so anyway, NYSEG sells energy, bloodsuckers. They sell kilowatt hours, which is power. Energy, if you think about it, is power times time. So kilowatts are power, it's a unit of power. It's just a bigger unit, and hours is time. So they're paying for, or we're paying for energy with them. Number 42, work causes potential energy or kinetic energy to change. If you go up to the top of the roller coaster, you're getting more potential energy, potential, and then kinetic! So it's going to become kinetic, and then you can get more potential and kinetic. All the work done is in the first hill, because from there on it just coasts. Potential energy and kinetic energy transfer back and forth. Potential energy versus height graph. Okay, take a look at this. Think about what the potential energy versus height graph and the kinetic energy versus velocity graph would look like. And I'll put them up here right now. So here's KE, and then this is the opposite order I set them, but we'll be all right. So to find out a graph, you'd find an equation. Directly related, they're on opposite sides of the equal sign, right? Directly related, and there's a squared, whoop, good job. And potential energy equals mgh. Okay, I'll wait for this one. Sarah Bransky? Yeah. What do you think it is? No squared, yes? Good job, Sarah. So that's what that's going to be. Looking on springs and Hooke's law. Springs, remember anything elastic, stretchy, like a booger, you know, has a nice little, well, anyway. That's going to be obeying Hooke's law. Hooke's law is an equation, F equals kx. And so if you have a springy thingy, and then you have a more springy, because now let's say there's a mass hanging on it, and say it's a 2 Newton weight. Remember, weight is in newtons. If you cover up just a little quick thing on the side here, W equals mg for weight equals mass times gravity. Weight is in newtons, so you cover up that and there's N right there. It's kind of cute, huh? But this would be the x, the distance that it stretched. So you'd have like 2 newtons. Say this is 0.5 meters. Okay? then that's going to be 2 newtons equals K times 0.5 meters. And so your K is going to equal 4 newtons per meter. Question, what would this graph look like? And this is force of a spring versus X. So based on this equation, what would the graph look like? Yep. And the slope of the graph is K. There's another equation that goes along with this graph. Potential energy, when you do work in a spring, you put potential energy into it. You take a slingshot, thump, okay? Say you're hunting some FFAs, then you're going to get some potential energy which becomes kinetic energy. So based on this equation, what does that graph look like? Yeah, I hope you got it. Heine, did you get it? There you go. It looks like that because of the direct relationship but squared. That is all for now. Thank you.